So this was 289, and it was find the first degree approximation and the second degree approximation for the function e to the x. At the point 2 comma e squared, and then it asks to graph all three functions. So the first part of this was to set the functions f of x equal to L of x, and the function e to the x at the point 2 comma e to the 2, which is equal to 7.389. And this is like the first part to find the linear approximations. So you're going to take the derivative of f of x and L of x. And the derivative of f of x is e to the x. The derivative of L of x, which is mx plus b, is just m. So m is equal to, m will be equal to e squared, which is equal to 7.389. And then you can plug that back into your function after you solve for b, or in order to solve for b, which would give you this. I'm not sure if I'm really explaining this right. It feels not natural. Alright, so I plugged my m in, which was the same thing as e to the x, or e to the e squared. Subtract it to the other side, and I got negative 7.7. So now that you know m, m is equal to 7.389. You know b is equal to 7.7, and you get e squared x plus, minus e squared, and that is your L of x that you're going to graph, which is this function. This is my L. This is the same as that graph. In order to find the second degree approximation, you start off with, what I did was I started off with right here my q, which was equal to ax squared plus bx plus c, which was given in the problem. I took the derivative of this, the first derivative, and I had 2ax plus b. And then I took the second derivative of this and got 2a. And I did the same thing for the original function, which was e to the x. And the first and second derivative is e to the x. Once you find the first and second derivatives for each one, you can set them equal to each other, which is what I did right here. Just set all of the functions equal to each other, and basically just like back substitute to solve for your variables. So right here I brought the second derivative up here. So 2a was equal to e to the x, which is 7.3. Solve for a is equal to 3.695. And then for the next step, set the first derivatives equal to each other. Solve for b, you get negative 7.3. Take this supposed to be. And then you take the original functions, set them equal to each other, and c is equal to 7.389. So once you find each variable, you can just plug it back into the original function, or into the original quadratic function, and you get basically 3.69 x squared minus 7.3x plus 7.3, which is this graph right here. And the original graph was this one, e to the x. questions? Yes.
Another question on your 2A. From my understanding, like your f prime of 2 equals e to the 2. I don't know if I'm not following something.
Hold on, where are you?
On 2A.
Right here?
No, up.
Right here?
Up. Right? No, down. The derivative of e squared?
Derivative of this?
Yeah. Like, are you taking the derivative of that, or does that stand for something else? Like,
Well, okay, what I did was, where I made the mistake was, I plugged in 2 first, and then I took the derivative, and I got 0, which was wrong. This actually should have been e to the x, not e squared.
Well, only if it's f of x, right?
Right.
No, only if it's f of x over there. Yeah, throw that mark in the trash so you don't pick it up again. There you go. F of x is e to the x, right?
Right.
So what's f prime of x?
E to the x.
E to the x.
Right.
So what's f prime of 2?
e to
E to the 2.
Right. I didn't write it out in all the steps. But yes, I just took the derivative of this first, and then once I got the derivative, then I plugged in f of 2, f prime of 2, which is e to the 2, which is 7.3, and that's where I got that from. And I just did the same thing with actually I probably shouldn't have this right here. Should have just done mx plus b, and then take the derivative, which is just m, which is just 2 whenever you plug in 2.
I think it's
Or,
having to
which
be,
is
like on f prime, are you not taking the derivative of e to the 2?
on which one? Right here?
Yeah, I think that's what has me confused. Like on b, you took the derivative of that line.
Right.
On top, are you taking the derivative of e to 2? Because wouldn't that just be 2e? Or do I not know how to
I'm taking the
write e?
derivative of this.
You can write it differently.
So let me write it out like this.
I'm sure lost.
So I took the derivative of f, which is f prime of x, which is still e to the x.
Okay,
And then-
so e, the derivative of x is e to the x.
Right. And
That's
then
that's what I'm confused. Okay.
I plugged in 2 for f prime of e to the x,
Okay, I'm with you now.
and that's where I got that from. I just like wrote it out in one step. Any other questions?
Could you explain to me how you got 2a up there is equal to e, or your e squared?
Right here?
Yeah. So see down here it's equal to your second derivative of q.
Right here?
Yeah.
Yeah.
A
So
equals 2a too.
So the second derivative of this function is 2a, right? So I just took this and set the quadratic function equal to the original function.
Okay.
The second derivative of the quadratic function equal to the second derivative of the quadratic.
Okay,
That's why I wrote this right here, so I could keep track of what I was setting equal to what. And then basically you just solve for a after that.
Okay. Thanks.
Does f prime give you your n?
Where?
F prime, does that give you your n? Or wait, what's n?
What is M right here? That's
Where did you get that? Is
I got that from this. This is like the first part. I probably should have wrote it like in order, but I just for the first part, for the first degree approximation, this was the given. Mx plus b was given in the problem. So what I did was I set them equal to each other. I set L of x equal to f of x. So now I have mx plus b is equal to e to the x.
You put in the 2s.
Right, then I plugged in 2. This is f of 2. And this was kind of like, this part goes that way also. Kind of confusing. It made sense when I was doing it, but it doesn't make so much sense when I'm trying to explain it. But basically, you set the two functions equal to each other. You take the derivatives, and once you take the derivative of Alright, once you take the derivative of L of x, which is equal to mx plus b, L prime of x is equal to m. F of x, which is equal to e to the x, F prime of x is still just e to the x, right? So then you set them equal to each other. M is equal to e to the x. So m is.
So your F
So whenever you
is
take,
your M.
yeah. So whenever you take f prime of 2 equal to L prime of 2, you get m is equal to 7.3, right? So that's where I got my m. I just wrote it as e to the x, but it's the same thing. You plug in 2 and then you solve for b like that. So once you know b, then you already know m, you just solve for b and you plug it back into mx plus b, and that's where you get this graph from. Am I saying that right? Okay.
You're looking for the tangent, right? You're looking for the.
Yeah, you're looking for the tangent at this point, which is 2 comma e to the 2. Just remember, whenever you take the derivative, because this is where I made a mistake the first time, take the derivative first and then plug in the point, because I did it wrong and I had a graph that was perpendicular to the point. Anything else?
Okay, let's go through Corey's and see if we need to revisit that. We can look at it again. Remember, the L is really just finding the equation of the tangent line, something you know how to do from Calculus 1. You don't have to do it the way we've done it here. You're just finding the equation of the tangent line. The advantage of doing it this way is it generalizes. That is, the way you find the linear is the same way as you find the quadratic. You set some equations up and you solve for the variables. So we'll